Students, I am your Kusum ma'am. Let's start with carbon and its compounds. So, today we are going to start out 4th chapter of chemistry of CBSE 10. So here, why we call them as hydrocarbons? Because the compounds are made up of hydrogen and carbon, they are called hydrocarbons. Now, hydrocarbons are of two categories. One is called saturated hydrocarbon and other is called unsaturated hydrocarbon. Saturated hydrocarbon are given the name of category as alkanes. So here unsaturated hydrocarbons are categorized as alkenes and alkynes. If there is single bond between carbon and carbon, then we call as alkanes. If there is double bond between carbon and carbon, they are called alkenes. And if there is triple bond between carbon and carbon, then they are called alkynes. Now the general formula of alkane is CnH2n plus 2. So this is general formula. If suppose the number of carbon is 1, we'll replace n with 1. So here C1 replace n with 1. Thus it is C 2 ones are 2 plus 2 CH4, which is first member of alkane derivative. Now for alkene, general formula is CnH2n. If we replace n with 2, so it's C2H, 2 2s are 4. So the formula will be C2H4. Now for alkyne derivative, if we replace n with 2, it will be 2 CH2 2s are 4, 2 minus 4 minus 2 is 2, C2H2. Now depending on number of carbon, different suffix are used and different prefix are given for the compounds. So here, if the number of carbon is 1, we use the prefix mith and then suffix as ane if single bond is there, ene as if double bond is there, and ine if triple bond is there. First we count out the carbon. As per that we give the prefix mith, and then as per the bonds different suffix are used. If the carbon is 2 in number, for 2 carbon compounds we call ith, for 3 carbon compounds prop, for 4 carbon compounds bute, for 5 carbon compounds pent, for 6 carbon compound hex, for 7 hept, and for 8 oct. So in your syllabus you are having up to oct, so it's sufficient if you remember this depending on the number of carbon atoms up to 8. After that we are going to add suffix as I told. If suppose one carbon is there, we call it as mith, as the first member is mith, and then if single bond is there we call ane. So methane is the first member of alkane derivative. Now carbon's valency is 4, so it will satisfy its 4 valencies with 4 hydrogen. If suppose it is satisfying its 4 valency with 4 hydrogen, now count out the carbon first. As one carbon is there, we will write the prefix mith, and we are seeing only single bond, so ane, thus the name is methane. Now if suppose 2 carbon compounds are there, so suffix is ith. As I told, if double bond is there we call as ene, so it is ethene. Again we are counting carbon 1 2, ith, triple bond is there, so ine, thus the name is ethyne. Then rest we are going to satisfy with hydrogen. Here already 3 valencies are satisfied, only 1 is remaining, so we'll place only 1 hydrogen. Again 3, so 1 hydrogen to carbon. We need to count out 4 valencies for carbon only. Here 2 valency is satisfied, so thus we'll add 2 more hydrogens. So thus carbon got 4, again 2 is there, so here 2 more hydrogens are added. So thus we can add out the valencies and we can complete the compound. Suppose they will ask to write the butane. If they ask to draw the structure of butane, so how we are going to add? We are going to divide the compound into 2 parts. So first bute is there, so add 4 carbons, 1 2 3 4 depending on prefix. Now ane is there, so this will identify that only single bond is there. Now count out the bonds. So here 1 is there, so 3 more are needed, 1 2 3 4, so thus it got 4. For this carbon 1 and 2 is there already for this carbon, so 2 more are needed, so put out 2 hydrogen. Here 1 and 2 is there, so 2 more are needed, only 2. Here again only 1 is there, we need 3 more. So here hydrogen is there. So thus we got the structure name. Now here 3 carbon are there. So the name is prop as per prefix counting. Now here, if suppose double bond is there, we'll call it as ene. Now count out the valencies. 1, 2. So 2 hydrogens are needed. 3, 4. 1, 2, 3. Already 3 are there. So only 1 hydrogen is needed. Here only 1 is there. So 3 hydrogens are needed. So simply you need to count out the hydrogen and to complete the structure. Depending on carbon, we give the prefix, and then depending on double bond or triple bond, we give suffix. Suppose here 3 bonds are there. So first we are counting carbon 1, 2, 3. Thus it is prop. Then triple bond is there. So for that ine, Y-N-E. Now count out the valency. 1, 2, 3. Only 1 is needed. 4. So 1, 2, 3, 4. 4 got completed. So no need of any hydrogen here. Here only 1 is there. So 3 hydrogens are needed. So thus the structure of propyne is completed. Students, let's start with functional group. So this video today I am preparing on behalf of my one of the oldest favorite student from Bharampur. So she demanded for having some more videos with carbon and its compounds. So this is the first basic which we need to learn from this chapter. So let's start out with functional groups. So here the first functional group is alcohol, where we add the OH functional group, and suffix added for this is ol. So as all of you know, while writing the names of the carbon compound, if they are single bonded compound with one carbon, the name is meth, and then we add ane in the last. So here for alcohol we remove this E and we add ol. Whenever alcohol is added, we add the suffix ol by replacing E from the name. So as I told, it is a single carbon compound. So here CH3 OH is attached. Now for ketone, I already explained difference between ketone and aldehyde. So here we are starting with aldehyde first. So aldehyde, there is an attachment of C double bond O H group. And I told you that here the carbon must be the last carbon. And we add suffix al. So as again the methane is there, the first member, replacing E with al. So for aldehyde we call it as methanal, and formula is HCHO, where CHO is functional group. Now coming to ketones. Ketone, the first member will have 3 carbons at least. So this is a very important point, don't get confused. The first member of this derivative is 3 carbon compound, where we are having the same structure like aldehyde, and here the suffix on is added. As the first member is having 3 carbon, so the name is given prop, and then ane E is replaced by ONE. For 3 carbon prop, and then E replaced by ONE, and the structure is 3 carbon with double bond O for ketone. Now coming to carboxylic acid. So here functional group is C double bond O OH. Here the suffix oic is added, oic acid. As again the first member is methane, we replace E with oic acid. So the name is methanoic acid, and its formula is HCOOH. COOH is attached at the end of the formula. Now coming to halogens. To halogens, chlorine, fluorine, bromine and iodine belongs, which we represent by X. So here R is representing some alkyl group. It can be methyl, that is if 1 carbon, ethyl if 2 carbons are there, propyl for 3 carbons, and whatever halogen we are adding out of these. Here we add IDE as a suffix. So here if 1 carbon is there, as I told, we'll be using methyl, and then I added chlorine, so it is methyl chloride. IDE is added. Okay. So here we need to add IDE. Now coming to ester. Ester derivative represented by R, R dash C double bond O. So one of the side I represented R and other side R dash. So these are representing different alkyl groups. So for example, it can be CH3, it can be C2H5, so on. For esters, we use the suffix ester only. Here I have taken the example of CH3 on both the side. So the name will be dimethyl ester. As methyl derivative is there 2 times, so we call it as dimethyl ester, or we can call it as methyl acetate. CH3COOH is called acetate, so we can call it as methyl acetate also. Hope everyone understood it. Students, let's start with bonding in carbon. So here, carbon's atomic number is 6. So thus its configuration, as the atomic number is 6, so its configuration is 2 and K. That is, in K shell, 2 electrons are there. In L shell, 4 electrons are there. To complete its octet, it can either gain 4 electrons, as 4 electrons are there in outer shell. So it can gain 4 electrons. So if it gains 4 electron, it will become 4 plus 4, 8. Or it can lose 4 electrons. Suppose if it is losing 4 electrons, it will have 2 electrons in their outermost shell. So thus it completes its octet. So what happens in both the cases? Let's get the more detailed understanding. If it gains 4 electron, carbon will have 10 electrons but 6 protons in the nucleus. So here the carbon is having 10 electrons in the outermost shell, as already it is having 4 plus 2, 6. So by gaining 4 electrons, 6 plus 4, it will have 10 electrons. Whereas the proton is having, 6 protons are there in the nucleus, which is quite difficult for the nucleus to hold. Thus it cannot gain electrons. So this is one of the important question, why carbon does not form cation or anion. Okay, that is why it does not gain electron or nor it donate electron. So the reason is, if it is gaining electron, you need to write an answer like, if it gains 4 electron, it will have 10 electrons, whereas the protons will be 6 only. Thus, it is difficult for nucleus to hold. Thus, it will not gain electrons. Now, in the simple way, like why it is not losing electron. So here, if carbon will lose 4 electrons from it, if the carbon will lose 4 electrons from its outermost shell, then it will have 6 proton in the nucleus, whereas only 2 electrons will be there. So thus again it will become unstable. So both the cases are not possible. Carbon can neither form cation nor anion. So it is one of the important question which you need to prepare for your board exam. Carbon is not forming cation or anion. So why? Only one line you need to remember, like if it will gain 4 electron, it will have 10 electrons, whereas 6 protons. So it will become unstable. If it lose 4 electrons, it will have 2 electrons and 6 protons. Again, it will become unstable. So stress on that point. Now the next important question is versatile nature of the carbon. So here we need to cover out with 3 points why we get more compounds with carbon. It is versatile means why more compounds are made up of carbon. There are 3 reasons for that. The first one, small structure. So as the structure of carbon is very small, it forms number of compounds. Now the second property is tetravalency. So how we get tetravalency? As I told, its atomic number is 6. So its configuration is 2 and 4. It needs 4 electrons to complete its outermost shell. Already we discussed, it can neither give nor gain. So only the possibility it share 4 electron. Thus it forms covalent compound. As it is sharing 4 electrons, so it is tetravalent in nature. You need to write that explanation. The next one, catenation. Catenation means to form long chain. Carbon combines with either carbon or some other atoms to form a long chain. So this property of forming long chain compounds is called catenation. So because of these 3 properties, carbon is versatile in nature. We get more number of compounds made up of carbon. So let's learn with next important question, that is homologous series. So students, you need to go with all the questions, all these questions which I'm making as a note or in the video. So all are turn-wise important, which you need to prepare either for 1 mark question or for 2 marks question. So simply by learning, you can complete this chapter, which most of the students feel difficult. So the next definition or the important topic is homologous series. So what are homologous series? Series of hydrocarbons where each member of the series differ from its preceding member by CH2 unit or by mass of 14 AMU. So what do you mean by CH2 unit? So here the first member is CH4, second member is C2H6. So this is methane. And the next one is ethane. Now what is the difference between them? Here 6 hydrogen are there, here 4 hydrogen is there. If we subtract, there is a difference of 2 hydrogen. In the same way 2 carbon and 1 carbon is there. There is a difference of 1 carbon. So thus both the units are differ by CH2. And if we calculate the mass, carbon's atomic mass is 12. Here 2 hydrogen are there, so 2, and hydrogen's atomic mass is 1. So 12 plus 2, it's 14. When they differ by either 14 mass unit or by CH2 unit, we call that series as homologous series. Let's start with next important topic, that is electron dot structure. So here we are forming the electron dot structure of hydrogen. As hydrogen molecule is there, so 2 atoms of hydrogen combined, these all are covalent compounds as they share their electrons. There are 2 types of compounds, one is called covalent compound and other is called electrovalent compound. So electrovalent compound, when there is complete exchange of electrons, they donate or accept and form ions and the compound is formed. As we came across the example of magnesium chloride. These are electrovalent compounds. But when the compounds are formed by sharing of electrons is called covalent compounds. Here hydrogen is a covalent compound. Hydrogen's atomic number is 1. So it has got 1 electron in its outermost orbit. So thus 2 hydrogen atoms will combine with each other. Means they are sharing their electrons. So thus they shared electrons between them. 1 electron of one hydrogen atom and other electron of other hydrogen atom. So there is a formation of hydrogen molecule. So when there is share of electrons, 2 electrons will make 1 bond. So this we are representing as a bond. Hydrogen, there is a single bond between hydrogen molecule. Now coming to one more example of oxygen. So oxygen atomic number is 8. So its configuration is 2 and 6. Now 2 atoms of oxygen, they are having 6 electrons in their outermost shell. So here they got 6 electrons. They come closer to each other and they share electrons between them. So there is a sharing of these electrons. Now when they share these electrons, there is an overlap. You need to draw 2 overlap circles. Here total 4 electrons are shared. 1 from the first one and again 1 more electron. So thus there is 4 sharing. Now remaining oxygen is having already 4 electrons. So whatever was the share, so that we combine. Now in the formation of the bond, like we represent for 2 electrons, 1 bond, again for 2 electrons, 1 bond. There is a bond formation. Now oxygen molecule is formed. So they'll ask how many bonds are there in oxygen molecule? There are 2 bonds present in between oxygen molecule, and this is its electron dot structure. Now coming to the structure of nitrogen. Nitrogen's atomic number is 7. So its configuration is 2 and 5. We need to count out how many electrons are needed in the outermost shell to complete its octet. So here 5 plus 3 is 8. So this nitrogen need 3 electrons to share. When we came across the example of oxygen, its configuration was 2 and 6. To make it 8, it need 2. So there was a share of 2 electrons. Now here nitrogen need 3 electrons. So one nitrogen atom, as it has got 3 electrons in the outermost share which it need to complete. So remaining 2 we will represent, only this 5 to be represented. No need of representing this 2. Innermost orbit is not needed. Only we represent the outermost orbit. Here 5 is there, and whatever the number you needed, that you keep together. Here 3 numbers are needed, so that 3 I kept together, and extra 2 as separate for the next nitrogen also. In the same way, 3 together and 2 separate. Now combine them. 5 plus 3, 8. Again 5 plus 3, 8. So this is the electron dot structure. Now there is a share of total 3 pairs. 1 pair will make 1 bond. So thus there are 3 bonds. Now this is the nitrogen complete formation, and we represent it as nitrogen atom where there are triple bond. For oxygen there is double bond, here triple bond is there. Now coming to the structure. So hydrogen is there that we are combining. So in this way we can complete electron dot structure. For carbon we need total 8. So sharing of 8, 2, 2, 2 and 2, total 8. And the same way for this carbon also will share total 8. So this is the electron dot structure. Now let's start with next topic. This is also one of the important question where they'll not be asking this whole properties. Separate questions will be made like what happens when carbon compounds are burned, or what is the oxidation reaction of the carbon compounds. Like separate properties you need to remember. This is not a long answer. To be done completely, you need to concentrate on each reaction separately. So here let's start with the combustion property. Combustion is nothing but burning. All of you already know burning means we need oxygen. So carbon in its all allotrophic forms. What are these allotrophic forms? Now the compound of carbon are made up of carbon only, but because of its different structural arrangement, they show the different properties. So those are called allotrophs. For example, if you see graphite or diamond, both are made up of carbon only, but their properties are different. Graphite, it is cheaper and it is used as lubricant or good conductor, whereas the diamond is the hardest and costlier. So thus the property got different. When the same compounds with the same formula have different properties, we call them allotrophs. So thus here carbon in its all allotrophic forms burn with oxygen to form carbon dioxide and heat. So here carbon is burning with oxygen to form carbon dioxide and heat. And the same way when it is methane, it also burns to form carbon dioxide and heat. If it is ethanol, again it will react with oxygen to form carbon dioxide and heat. So already we discussed all the functional groups. When OH is there, we call it as alcohol. 2 carbon is there, so it is ethanol, ol for alcohol. So everything, any carbon compound when it burns, it forms carbon dioxide and hydrogen. With this you can remember. Now next is oxidation. Already in chapter 1 we came across oxidation, that is addition of oxygen. Here I have taken the example of ethanol as 2 carbons are there. So it is ethanol. Ethane, E is replaced by ol for alcohol group. In presence of alkaline KMnO4 or acidified K2Cr2O7, that is potassium dichromate, as oxidation is there, number of oxygen must increase. So here 1 oxygen is there, it got increased with 2 oxygen, CH3COOH. So you can see here the number of oxygen is now 2. As the carbon number is 2, so we call it as eth, and then acid derivative is there, so it is ethanoic acid. On oxidation, ethanol get converted to ethanoic acid. So concentrate on the reaction. Ethanol converts into ethanoic acid, that is alcohol convert to carboxylic acid. As here K2Cr2O7, that is potassium dichromate, is used as oxidizing agent. So the agent which adds oxygen in the reaction or which helps in oxidation are called oxidizing agent. They can ask one more question in this way: what are oxidizing agent? So the different chemical compounds which are used to increase oxygen in certain reaction are called oxidizing agent. They are providing oxygen. Now the next chemical property is substitution reaction. So the methane, or when the carbon compounds undergo substitution. So here we have taken the example of methane when they react with chlorine. So here the presence of sunlight is needed. This is as a catalyst. They can ask in 1 mark question, what is the catalyst during substitution reaction? So sunlight you need to remember. Methane in presence of chlorine. As here substitution reaction is there, one of the hydrogen will reduce and chlorine will get added. Here 4 hydrogen are there. So the number of hydrogen is reducing, CH3. From 4 it will become 3 and 1 chlorine is added. Now what about that liberated hydrogen? So that hydrogen will combine with this chlorine and it will form HCl. This is substitution reaction. And this compound is called methyl chloride. Now the next property, addition reaction. As the name itself signifies, something is added. In addition reaction, here we remove this double bond, which we call unsaturation, and the unsaturated compound will become saturated, means they will become single bonded compound. And here the catalyst is nickel. This is also important. 1 mark question they can ask, in which catalyst addition reaction will take place, or hydrogenation reaction. This we call hydrogenation also, as hydrogen is added. Here unsaturated hydrocarbon in presence of nickel and hydrogen will convert into saturated hydrocarbon. So as in this reaction unsaturation is removed, this is also called addition reaction. And one more, this is the reaction where vegetable oils are converted into ghee. So here oils are unsaturated hydrocarbons which are good for our health. In presence of hydrogen, they get converted into saturated, which is more fatty in nature. So this single reaction they can ask in 3 different ways, either by addition reaction, or by hydrogenation reaction, or by formation of ghee from vegetable ghee from oil. Now let's start with properties of ethanol. So here in your textbook, 2 different chemicals are given. One is ethanol and other is ethanoic acid. They can make questions based on properties also. So let's start out with the property of ethanol. Now we are learning about the physical properties. The first one, ethanol is liquid at room temperature. Its boiling point is 156 Kelvin and its melting point is 351 Kelvin. So here boiling and melting point is given. Then commonly it is called alcohol, important ingredient in alcoholic drinks. So it is one of the important ingredient in alcoholic drinks. Its pure form is called absolute alcohol, where there is 90% alcohol and 10% water is there, which is called absolute alcohol. To avoid its use, it's mixed with methanol. Then it is called rectified spirit. So all these they can be the separate 1 mark questions. You need to learn out all the properties. What is rectified spirit, or what is absolute alcohol, or what is melting and boiling point of ethanol. So like that they can make the separate questions. Now uses. Used in medicine like tincture, iodine, cup syrups and many tonics. So it has got beneficial effects also. It is used in medicines, mostly in the cough syrups. Now coming to the chemical properties of ethanol, the first one is reaction with sodium. When ethanol is reacted with sodium, so here sodium will add up and this hydrogen will get replaced by sodium. So simply you can remember reaction ethanol CH3 CH2OH. When we are adding sodium, so here oxygen will remove from CH3 CH2OH, that is CH3 CH2ONA. In place of hydrogen I added sodium, and that hydrogen which got removed will be liberated as hydrogen. So this compound is called sodium ethoxide. Now the next reaction is reaction to give unsaturation. Unsaturation means to form double bond. So here ethanol in presence of concentric sulfuric acid. This reagent you need to remember. Ethanol in presence of concentrated sulfuric acid will form into ethene. That is here OH and 1 hydrogen from here will get removed. So if we remove 1 hydrogen, we are left out with 2 hydrogens, that is CH2. As water is removed, to satisfy carbon's valency, it will form double bond. So as double bond is formed, this is called unsaturated hydrocarbon, that is ethene. For double bond we use ene. As the sulfuric acid is used to remove water, so it is also called dehydrating agent. They can ask, give example of dehydrating agent. We need to write concentrated sulfuric acid as it removes water. Now properties of ethanoic acid. This is the next topic which you need to remember. Again we'll discuss about the physical properties of ethanoic acid, that is commonly called acetic acid. Another name of ethanoic acid is acetic acid. 5 to 8% of acetic acid in water is called vinegar. Again they can make what is vinegar, that is 5 to 8% acetic acid in water is called vinegar. Its melting point is 290 Kelvin, whereas the boiling point is 319 Kelvin. Now it freezes during winter. If it freezes, we call it as glacial acetic acid. So this often you might have noticed, like if we keep the pickles in refrigerator, we can. Now let's start with chemical properties of ethanoic acid. This is also separate question important, like what is esterification, what is saponification, most important question which we get very often in board exam. So here, The first chemical property is called esterification. The name itself suggests that ester is formed. So what is esters? C double bond COO compounds are called esters. So here ethanoic acid reacts with ethanol. Okay, ethanoic acid react with ethanol to form ester. So here water will get removed. So here remove one hydrogen and OH. So what we left with? CH3COOH. So that I wrote as it is, and then this remaining C2H5. So here this is called ethyl acetate, or we simply call it as ester. Ethyl acetate or ester. As during this reaction ester is formed, this reaction is called esterification reaction. Now esters are sweet smelling substances generally used in perfumes or flavoring agent. Like if we want to give flavor to any eatables, then this esters are used. Again, this can be the separate question. Next one is saponification reaction. So here saponification, again the name itself suggests that this is a reaction where soaps are prepared. Now here ester get converted to alcohols and sodium salt of carboxylic acid, like the reverse of the previous reaction. When we reverse, that is from the ester, if we go back, we get again carboxylic acid and alcohol. So that reaction is called saponification. Now esters get converted to alcohol and sodium salt of carboxylic acid. This reaction is known as saponification because it is used in the preparation of soap. Why we call it as saponification? Because it is used in preparation of soaps. Now what are soaps? Soaps are long chain of carboxylic acid. Now here the salts can be either sodium or potassium. They can be the salt of sodium or potassium. Now coming across the reaction. So here it is ester. Already we discussed ethyl acetate. Ethyl acetate in presence of NaOH, it will get back to ethanol and sodium acetate. So this the previous reactions reverse. That is, in previous reaction esterification, from alcohol and acid we prepared ester. Here from ester we will go back to alcohol and acid. So this reaction, this part is called soap. So as this reaction is used in the preparation of soap, we call it as saponification reaction. Now the next topic is reaction with base. Already we know when acid react with base, there is a formation of salt and water. So basic reaction where we came across acid base chapter. So here sodium hydroxide, when it react with ethanoic acid, it will form sodium salt of ethanoic acid, or we can say sodium ethoxide. This is sodium ethoxide and water is liberated. Now the next reaction with carbonates or hydrocarbons. So this also we came across acid base chapter. Whenever any acid reacts with carbonate, it forms sodium salt of acid plus water and carbon dioxide is liberated. This is the basic key of the reaction. If you learn it in one chapter, follow the same for every chapter. Now here the ethanoic acid is reacting with the sodium bicarbonate. Same result again. It will form sodium salt, that is sodium ethoxide, water and carbon dioxide is liberated. This is the last topic of the chapter, soaps and detergents. So this is also one more separate question. Now here how the soaps and detergents are prepared, or what are soaps and detergents. So here the molecule of soap are sodium or potassium salt. So this is potassium, sodium or potassium salt of long chain carboxylic acid. Here you need to remember what is soap. They are the molecule where they are the salt of sodium or potassium, and there is a long chain of carboxylic acid. So here it has got two parts. One is ionic and other is hydrocarbon tail. So you can see the soap where there is hydrocarbon tail and ionic part. This is ionic part is made up of sodium or potassium salt, whereas this tail is made up of carbon and hydrogen. And their properties, ionic and it interact with water. That is, it is water lover. And hydrocarbon tail, it interact with oil or dirt. We can say that it is hydrophobic in nature. Okay, this is hydrophobic end and this is hydrophilic end. Now coming to action, how soaps and detergent act. When soap or detergent are applied on dirt, the tail part will attach with dirt, whereas head part will remain outside the structure. Okay, outside. Here when we are adding soaps or detergent, as we are adding that to dirt, so here the tail part will go and attach with the dirt. Okay, here if it is dirt, the tail part is getting attached. If here dirt is there, the tail part is getting attached to dirt, whereas the head part will remain in water. So this structure is called micelle formation. So this is again one more question. What are micelles? So after applying oil or after applying soap or detergent to oil, they forms a structure where the tail part of the detergent will attach to the dirt, whereas the head part will remain in water. So the structure is called micelles. Now it forms an emulsion with water. So when it is applied, it forms an emulsion like foam-like structure. Thus will help in pulling dirt in the water. So when we acetate clothes, dirt will be pulled along with the tail as the tail is attached with the dirt. So the dirt will get pulled and then water will become dirty and cloth will become clean. So thus it helps in pulling dirt in water and making the clothes clean. So this is the cleansing action of the soap and detergent. For this question, they can ask how soaps and detergent are acting or the cleansing action of the soap and detergent. So hope everyone understood this chapter. Simply go through with the video for twice or thrice. You'll get the whole chapter in single shot. Please like and subscribe for more videos.